Alrighty, hi everyone. Welcome. We'll get started right away since I know we only have an hour. Sorry, this was a last minute Zoom announcement. I am simply just very busy. Okay, so I have one request. So for this session, you can just ask your questions in the chat or just say them out loud, like if I'm talking to you during a question. I do have one request to go over P8, which is why I'm starting it right now. So we'll do that first, and then if you have any questions along the way, just ask it in the chat or just take yourself off mute and you can ask it that way. Okay, so for question 8 on the practice exam, this is the one that we were kind of going back and forth about. So the question says at 700 degrees Celsius, Kp is equal to 5.34 for the reaction H2 gas, CO2 gas, goes to H2O gas and CO gas. How many moles of H2 would be present at equilibrium if a mixture of 0.3 moles of CO and 0.3 moles of H2O were heated to 700 degrees Celsius in a 10-liter container? Okay, so one thing that you always want to note is which way your reaction is happening, right? You always want to be able to solve for Q to determine if you're at equilibrium or not. Okay, so if we write this reaction, the way that it's given in your question, you have H2 gas plus CO2 goes to H2O and CO. Okay. So if we were to write the K for this, the Kp for this reaction, what would Kp look like? What's going on top here?
Pressure of H2O times pressure of CO over pressure of H2 times pressure of CO2.
Great. Okay. So again, this is still products over reactants. So we still have our products of our gases over our reactants of our gases. So then the next thing to ask is, what do we know? What do we have given from our formula? So we're given Kp, but what is the concentration that what are we given from our question? What units?
Moles.
We're given moles, right? Can we do Kp in moles?
No.
No, we cannot. So the first thing that I would recommend doing is changing those 3 moles of, or those 0.3 moles of H2O and CO that you have into a form of pressure. And what equation are we going to use in order to switch from moles to pressure? Good. Yep, we're going to use PV is equal to nRT. Right, we don't know pressure, so P will be equal to that 0.3 moles times 0.08206 times temperature in Kelvin. So this is 973 all over 10.0. Any questions so far on that?
Where did you get N?
Yep, so N came from the question. It was, you have 0.3 moles of CO and 0.3 moles of H2O. Does that help?
Okay, so that one would be given, and then obviously that the 0.082 is a constant, and then what is on the bottom? Where'd you get the 10?
The 10 is also from the 10-liter container.
Oh, okay, I didn't see it on the second page. I was like, where is that? Okay.
Yep.
Thank
Yeah,
you.
sorry, this one breaks. Sorry. Yep. Okay, so we could find a pressure. And I actually don't know what that value is. But you get a pressure, right? So this would be something. If you look at the answers that I posted, my worked out solutions, you can see that I used 0.3 directly. Can someone tell me why we can still use 0.3 here?
Because the 2 zeros at the end don't affect it.
Sorry. Not in terms of sig figs, but why can I use my moles concentration, or like why can I use molarity and not have and why do I not have to change it to a pressure?
Because it's a 1-to-1.
Perfect. Yep. So when we look at your equation, your chemical reaction happening, we have 2 moles of gas on your reactant side and 2 moles of gas on your product side. If your moles of gas on your products and reactants are equal, then Kc will equal Kp. Okay, so even though we said that we don't use pressure or we don't use concentrations or moles here, we can because your reactants and products are equal in their number of moles. If we only had 1 mole of gas on the left and 1 mole of and 2 moles of gas on the right, then that would cause us to have to change this to pressure, but we can just use our concentrations here because Kc will equal Kp. Does this make sense? Okay. So you can either find a pressure like we did in red, or we can continue in purple and we can just use our Kc concentrations. Which way do we want to do? Do we want to use pressures or do we want to use concentrations?
Can we do
No.
pressures since they won't always be equal?
Sure, absolutely. Okay, so what is the pressure that we get from the 0.3, the 0.08, the 973, and the 10? Let me grab my calculator, because I didn't do it. Awesome. I got 2.395 ATM. Perfect. Okay. So once we have that, we can now start plugging in our ice or rice table. Okay, so if we're going to plug in ice, what can we fill in from our question so far? What does that 2.395 correlate to? What part of our chemical reaction was our products? Good. Yep. So this is going to be 2.395 and this will be 2.395. Because we say that a mixture of 0.300 moles of carbon monoxide and water were heated. So those are now what we have values for, initial concentrations for, initial pressures for. What does that mean for H2 and CO2? What are those initial pressures? Yep, those will be 0. Okay, so which way is our reaction going to go? It'll go towards the left, right? It'll go towards our reactants. If we solved for Q, we have 2.395 2.395 over 0. Okay, Q is going to be a lot greater than K. Q right now is at infinity. Okay, that's going to be greater than K, so we have to proceed towards your reactants. What does that mean for our K value? Can we use the K given? No, we cannot use the K given because the K that we have is for our products on top and our reactants on the bottom. But what the reaction is actually happening is your products are now your reactants. So the actual equation that's happening is H2O plus CO goes to H2 and CO2. This is now 2.395. This is 2.395. This is 0. This is 0. And then now it's like reactions going to products. Does this make sense? You could still do it where your products are on the right and your reactants are on the left. That's definitely true. You can definitely use K that way. And you can do your whole problem that way too. I personally like to see all of my reactants going to products, but I know that that means that I have to take Kp, which is equal to 0.534, and put that to the -1 power because now I need the inverse. Now I need to know what happens when I have the H2O and the CO as reactants and not the products. So Kp for now, this forward reaction in blue is 1.87. What questions do we have about what I just did? Who was lost? Who needs to see that again? Or are we okay? I'll give a second. Yes, this only happens when the products have moles and you have no reactants. Jackson, you totally could do it from the products. I personally just like to see everything going from reactants to products, and so I switch it. But if you are, I just like working left to right. If you can work right to left, then by all means, you can do it that way too. I'm just showing if someone likes to see it left to right, I'm just showing you that's how I do it as well. I make less mistakes that way. Okay, so now this is our new ice table. So what does that mean for our change? What's happening to H2O and CO? The 1.87 came from the inverse of Kp. So the Kp that we did over here, this one over here, this is for when our H2O and CO were products, but now I need to do it so that the H2O and CO are reactants because I switched them to be reactants instead of products. I'm doing the reverse equation. Yep. If you didn't change it, then you would be using the 0.534 for your K if you kept your products as they were. Okay, so for change, it's still going to be -x and -x, plus x and plus x. If we were to fill out this one up here, this would still be -x, plus x and plus x. So then at equilibrium, I'll fill this one in case you're doing it right to left. or it'll be right. So it just depends on if you're doing reactants to products or products to reactants. Okay, how do we solve for X in order to find how many moles of H2 would be present? Yep, now we can just plug it into K. So we can say and then if you're in purple, then you would say that. So those are your two options that you have. Can we use our assumption rule here? Assumption, yes or no? Nope, we can't. Does anyone know the rule for the assumption? So your assumption is you are neglecting X. Not neglecting X, but neglecting the minus X, that change in X. If KP equals 1 times 10 to negative fifth or less. Or and you get a smaller number, right? So you have like a -5, a -6, a -7. So it's less than or equal to. Is less than or equal to 1 point times 10 to the 5. Okay, so our K's here are either 0.3 or 1.8, so we cannot use the assumption here. So either way, you have to use the quadratic formula. And your quadratic formula is x equals -b plus or minus square root b squared minus 4ac all over 2a. I'm sure y'all all know the jingle at this point. So then you can plug in after you FOIL your fractions, get them all to one side, isolate x and make x equal or make that whole side of the equation equal to 0. Then you can do the quadratic formula and you'll end up with that 0.137, I believe it is. Yes. Does that help with question 8? Yes, you could do that, Jackson. Right, so you can say, we'll just do this in purple. Right, we can say 0.534 is equal to 2.395 minus x squared over squared. I do believe that will give you the same answer since both the top and bottom are squared. You can take a square root and that'll just get you a singular x, then you don't have to use the quadratic formula. I just tend to do the quadratic formula by habit. Yep, so for the ICE table, I'll just put it in question 9. This is your initial, your change, and your equilibrium. That's what ICE stands for. Sometimes people call it RICE because they put the reaction at the top too. I tend to just write the reaction and then do my ice table afterwards. It's just a personal preference. But your initial is the starting concentration or pressure. So this will usually be given to you in the question, or you're given an equilibrium value, and based on values that are given to you in the question, you might be starting with the equilibrium, and then you can get back to what that initial pressure was, or initial concentration was. Erica, I'll answer your question once I finish this. So that's going to be your initial concentration or pressure. If you're starting in initial concentrations, you want this to be in molarity. So moles over liter. And that would be for Kc. And then for Kp, you want this to be an ATM. Or just not necessarily ATM, you just need a pressure unit and they all need to match. ATM is just the most common. If you're not given any information about the reactant or product in your question, then you can assume that it is 0 and you do not have a starting concentration for it. Your change is going to be how the reaction changes or how the reaction proceeds. How the reaction happens, right? If you're given reactants and no products, then you have to make products, right? If you're given, right, A plus B, and you're given 2 molar of this and 0 of, or not A plus B. If you're given A goes to B, and you're given 2 molar as your initial and 0 as B, then you have to form products. You have to form that B. So that change is how much of A is going to be used up in order to form B. And that's all based on your molar ratio, 1:1. So since A here is the same stoichiometric ratio as B, then it would be minus X for A and plus X for B. If we have A goes to 2B and we had 2 molar and 0, then this would be minus X and this would be plus 2X because there's a 2 in front of that B. Equilibrium is going to be your concentrations at equilibrium. Right, so once the reaction is done changing, once all of the reactants are going to be formed and all the products are formed, and you've reached that happy middle ground of the reaction going forward in reverse at the same rate, then that will be your concentrations at equilibrium. Again, those are in the same concentrations as your, or same units as your initial concentration or your initial pressure. And that is most often the combination of your initial and your change. So equilibrium for this A and 2B one here would be 2m minus x and then plus 2x. That, or you don't even need the m here. This would just be 2 minus x and then plus 2x. Those would be your equilibrium concentrations. And that is an ice table. Yep. Okay, and then Erica, for your question on the quadratic formula, do I have something in here? I do not. So basically for the quadratic formula, if you have 2 minus x and 4 minus x, right, we'll just call it that. You're going to FOIL out your method, your equation. I should have done this backwards. It doesn't matter. Right, so you're going to have 2 times 4. That'll be 8 minus 2x minus 4x plus x squared. If you rearrange that, you'll get x squared minus 6x plus 8. And this is A, B, and C. So in your negative B for this one here, you'll have, right, it's negative B. Here, B is already negative, so you'll have negative, -6. So this would just be 6. when you're plugging into the quadratic formula.
So for that specific question, am I foiling the 2.395 minus x?
Yes, yep. So you would
Okay.
do, yep, so you would do 2.395 times 2.39, right? You go here to here, and then here to here, and then here to here, and here to here.
Okay, yeah.
Yep.
So, and then x is gonna be the 0.173, right? Or
Yes,
no?
at the very end, like once you do the quadratic formula, then you would get x equal to 0.173. Yep.
Then this could be a really stupid question. Does it really matter which way? It doesn't really matter which way you go then for like when you did the inverse or the -1 when you switched it?
Nope,
Okay.
it does not matter. As long as you just need to make sure that your K matches the equation you're working with, right? So if you flip
Gotcha.
it so that it's reactants to products, then you need to make sure you use the inverse K, because now you've switched which way you're working. If you just
Okay.
work with it so that the products were it, then you can keep the K, the 0.534.
Okay, thank you.
Great question. Alrighty, anything else on just like 8 in general, quadratic formula in general?
Actually, could you for the starting, the very first equation that we use, the Kp is equal to, is that supposed to be products over reactants? Or is it reactants over products?
In red up here.
Yeah.
Yep. So this was for if you're matching, like this goes to this one right here. The equation in purple. So now that is products over reactants because you have H2 and CO on top as your products, and then or you have H2O and CO as your products, and then your H2 and CO2 as your reactants. If we were to write the Kp for this one would be H2 and pressure of CO2 over pressure of H2O and pressure of CO.
Okay, so you don't necessarily have to start with the red one.
No, nope.
Okay.
Hey, Nora, that's a great question. Do you have this type of calculator where it's more of a for function, or do you have a graphing calculator? Okay, so if you have a graphing, that makes it heck of a lot easier. The thing you just need to note, or you need to like be aware of are your parentheses. So if you can get your fraction, right, you should have a box with your fraction. In this top one, that's where you plug the top of the equation, and then 2a will always be in this bottom one. 2a will just be by itself on the bottom. In terms of parentheses, I would do a negative and then parentheses, whatever your b value is. So in this case, we said it was -6, right? For that practice one we were doing, right? We said it was x squared minus 6x plus 8. If we're going to practice this, right? So that's negative b. You cannot do plus or minus at the same time. You have to pick either plus or minus. I recommend doing the plus first. So you'll have plus the square root. Again, you want parentheses over b. So it'll be -6 squared minus 4. I would do parentheses a. Here is 1. C is 8. That'll be in that top box of your fraction. And then all on the bottom would be 2 times 1. And then you can hit enter, and then it should do the whole thing for you. Yep. Anything else on the next couple of ones? I have a request to go over 11 and 12 on the practice exam. I'm gonna be completely honest, I looked at both of them for about 2 minutes, and that's all I could give it, so I don't know actually how to do them. If someone knows how to do them and you wanna help me walk through it, I'm happy to go over it, but, like, I do not have answers for them. I just simply ran out of time. Yep, I could do practice 7. Okay, so for question 7, we have consider the reaction N2O4 equals 2 NO2 gas at 100 degrees Celsius. The equilibrium pressures in a 3.5 liter chamber were 0.737 and 0.169. At some time, the additional N2O4 was added such that the pressure doubled. And what would the resulting pressure of NO2 be once equilibrium was reestablished? Okay, so one thing you always want to ask yourself, is K changing? And when does K change? Capital K. When does capital K change? Good. Capital K only changes with temperature. Okay. So what we need to do first is we need to find what this K value is. We're not given a K value, but we can find it because we're given this and this in our question. So that's like initial K, right? So what would K be given 0.737 and 1.69? What's going to go on top and which one's going to go on bottom?
Once 1.69 at the top and 0.737 at the bottom.
And do we need to change anything about either one of them? Or do we need to add anything to either one of them? Yep, we need to square the top. Right, this 2 here, our 2 NO2 means that we have to square it in our K expression. Okay, so K here would equal we got 3.875. Okay, I'm just gonna move. Okay, so now that as our it is squared because we have N2O4 is in equilibrium with 2 NO2. And so that coefficient of 2 in front of the NO2 means we square it in our K expression. Okay, so now that we have our K established, we're now saying that at some point the additional N2O was added such that the pressure doubled. So what is our pressure of NO2 now? I'm sorry, not of NO2, of N2O4. What is that when it's doubled? How do we double N2O4?
When N2O4 is doubled, you get approximately 1.474 ATM.
Awesome. Yep. So it's 1.474 ATM. We just took 0.373 times 2. Okay, so if you were to write an ice table for this, we would have N2O4 and 2NO2. This would be 1.474. What is our initial for NO2? It's not none this time, right? We're given an equilibrium of the 0.737 and the 1.69, and now we're doubling the N2O4. But that still means that we have 1.69 available in our container for the N2O. Or I'm sorry, the NO2. Okay, so that 1.69 is still there. So if we solved for Q would be 1.9 squared over 1.474. I'll tell you Q is less than K, so this means we have to go to reactants. Or not reactants. Oh boy, it's late. We have to go to products. Okay, if we're getting products, what does that mean for our change? What is the change of N2O4 going to look like? Close. Change is just going to be minus X because we just have a 1 in front of the N2O4. And then the NO2, that's where it's going to be the plus 2X. So at equilibrium, we have 1.474 minus X, a 1.69 plus 2X. Any questions, or what questions do we have about that setup? Okay, so once we have equilibrium, then we can use that K we found first and plug our equilibrium concentrations now into that K. So we can say this would be 3.875 equal to 1.69 plus 2x. What do we have to do to this 1.69 plus 2x? Yep, we have to square it. And that'll be all over 1.474 minus x. Okay. When we square this top one, it's not just squaring 1.69 and squaring 2x. This becomes 1.69 plus 2x times 1.69 plus 2x, right? You have to FOIL it out. So this does take a little bit of math, but it does, you can FOIL that out. You can cross multiply and distribute the 3.875 to the 1.474 and the minus x. You can combine your like terms and get an x squared, a b with an x, and then a c value equal to 0, and you can plug it into the quadratic formula. You cannot use your assumption here because we do have a greater than 1 k. When I did this, I get about 2.06 after the quadratic formula, because you're going to solve for x, and then you need to add that to the 1.69 plus 2x. Oh, and I realize right now in my answer key, because I'm looking at this to make sure I'm doing things correctly. In my answer key, I only put plus x in my ICE table and not plus 2x, and so that's why I have a slightly different answer. But x should be around, I think, like probably 0.4-ish. Okay, does that help with question 7? Okay, and then we do have time for one more, so I'll go over question 6, because I just got 2 requests for that one. Okay, sorry, this is hard to see. One moment. Okay. Okay, so here we have H2 gas plus I2 gas goes to 2HI. Okay, and the question is, so we know that that is our reaction, and the rate law is R is equal to K H2 times I2. Free iodine atoms I have been detected as an intermediate. Which two-step mechanism is consistent with the information? Okay, so first thing you have to ask yourself is, what is an intermediate? So can someone define intermediate for me? I guess. Yep, so your intermediate will get used up in reaction, but that means that it has to be produced and then consumed. Okay, so it cannot be a reactant in your first step. It has to be a product of your second or third step if you have more than one. Okay, can intermediates show up in your rate law? Nope. And then lastly, which one is the rate determining step? The slow or fast step? Yep, your slow step is rate determining step. Okay. So the next thing that I would do is I would almost write out all of these in like 1 and 2 steps. But the other thing that you can look at is that you can say, okay, I know that my slow step will be my rate determining step. So if I look at choices B, C, and D, okay, that means that the slow step is what I would write my rate equation from. So if we're going to write the rate equation for B, we're going to say R, or rate, is equal to K. It's just the reactants that go into your rate determining, or your rate law, which is just H2. So rate would be equal to H2. Okay, does that match the rate law given in our question? Nope, it does not. So that means we can immediately eliminate that question, or that answer choice. Okay, if we're going to do that for C as well, right? Their slow step is our first step. So rate is equal to K times I2. Does that match our initial rate law given? Nope. And lastly, for step D, we have rate is equal to K times I2. Again, does not match, so we can eliminate that one. Right, you can also eliminate B, because B does not produce I as an intermediate step, or as an intermediate, but in C and D, we do see that intermediate being produced. Okay, so that's one that might like trick you up a little bit. So now we're left with none of the above or A. So now we have to check A. For A, our step 1 is fast. Okay, so that's an equilibrium. But then step B is our slow, or step 2 is our slow step. So what would be the rate law for our slow step? It's gonna be K. What are we multiplying by? Good, right? We would say that this would be H2 I squared. What's the problem with this rate law? Not the squared. So the
Is it the
problem,
I?
yep, the I, this I here cannot be in our rate law. Intermediates cannot go in the rate law. And so instead, we have to do a little manipulation. So we can say that in step 1, this fast step, this is now in equilibrium. So we can say that K is equal to I squared over 2I2. Right? We call that like KEQ, right? Is what looks like on your homework. Okay, we can solve for I squared, and we can say that KEQ times I squared, or I2, is equal to the concentration of I squared. Now we can plug in this here. So we get rate is equal to K times H2 times KEQ times I2. Okay, big KEQ here is a constant. This is a constant. So little k times a big K just makes a new K, right? It's a number times a number. It just makes a new number. So these can combine to say that rate is equal to K H2 I2. And does that match the initial one in our question? Yes, it does. Yep. So A is good to go. And we know that it's A over E. Okay, does that help with P6? What other questions do we have about question 6? Okay. Yes, so I had a question to explain why we can get rid of KEQ. We're not like getting rid of KEQ. If little k was equal to 2 and KEQ was equal to 4, those are two constants. They're going to be 2 and 4 no matter what. So we can always multiply a constant by a constant to get 8, right? So that k that we're given would be 8 in our case that we created. But you can combine those because they will just be values, and it's not like they're entities, right? They are just values that can be multiplied whenever. And so you're just making a brand new k, right? It would just be the k in your rate law would be the combination of little k and KEQ. Yes. So then I have another question that says, so the intermediate can never be in our rate law, and it is found in the slow step. We need to replace it with info from step 1. And yes, this is true. At the end of my video from yesterday, a student came up to ask me a question about this, And on the board, I kind of walk through what like a 3-step would look like. I'm not entirely sure if you can see it. But I talk through like what that would look like in terms of if your slow step was the 3rd step, and you always have an intermediate, what that would look like. But intermediates could not ever be in the rate law equation. You have to manipulate the other stuff that you know in order to get rid of that intermediate. I had a last minute question for 10. I cannot do all of the math in this time, I think, but I should be able to talk through it here. Okay, so for question 10, we have at 375 degrees Celsius, the equilibrium constant for the reaction there is K is equal to 1.2. And at equilibrium, the concentrations of N2, NH, and NH3 were those respectively. We want to know what the concentration of H2 is at equilibrium. Okay, so for this one here, you need to know what K would look like. And so I wrote that out first, and I said that, right, your product is your NH3. So that's going to go on top. It has a 2 coefficient, so that means it's squared. Your N2 and your H2 are your reactants, so those are going on the bottom. There's a 1 for your N2, so that gets a 1 coefficient. And there is a 3 for your H2, so that gets a 3 exponent. I said coefficient. There's a 1 exponent, 1 coefficient over here, 1 exponent, 3 coefficient, 3 exponent. So then you have to ask yourself, what do I know from this equation? We're given K in our question. And then, so that can be 1.2. We are given 0.00582, and that's going to be NH3 respectively. So that's going to be on our top. And then N2 is 0.071. So that's going to go down here. You're going to solve for x cubed, and you have to take a cubed root in order to find x. And I believe he came out with an answer saying that it's 0.0735 instead of the 0.00735, and there's just a typo. But yeah, it should be 0.035. 0.0735, excuse me. And this is put up on Canvas with the other stuff, if you want to look at the math again. Okay, any other last minute questions? Right, if you get super desperate tomorrow solving for X, it is a multiple choice question. Plug in an X, see if something works. Might get a little tedious plugging it all in, but you might get the right answer. Think about all of your questions before you make an answer choice. This will be a long exam, right? There's a lot of math going along. Make sure you stay ahead of your time. Dr. Lindahl is not keen about interrupting you, so you just have to briefly look up at the board to make sure you can tell what time it is, or just wear a watch so you know what time it is as well. I will not finish working out 11 and 12. I'm sorry. I have a 12-page paper due next Friday that determines if I'm going to be a PhD candidate or not. I just do not have time. And then, so I apologize for 11 and 12. But I believe in all of you. You are able to solve them. I promise. And then, I think you're allowed to wear Apple Watches. He hasn't really said anything. Just don't do anything sketchy, okay? Just don't do it. It's not worth it. It's just one exam. It's just not worth it. And then anything else I need to say? And just make sure you're checking your bubble sheet. At the very end of the day, just make sure that all of your answer choices match the ones that you want. I take all of your Scantrons afterwards and I scan them, so I have a copy of what your Scantron looks like. And I'm just gonna say one thing. Please be nice to me if I make a mistake with your grade. I use technology to help me out grading your stuff. Something might get marked wrong when it should have been right. Please just ask me to review it. Please don't tell me I'm wrong. It is not nice to hear. I will admit if I am wrong, but please do not straight up tell me that I am wrong. That is all I have to say on that. I am happy to help you with any of your grade choices or your grade stuff, discrepancies that you have. Just please be courteous. I am also a human under a lot of stress. But if there's no other questions, I'll hang around till 9:30 before signing off. But good luck tomorrow. I believe in all of you. I hope that this has been helpful. I hope you are learning things, and then I will be posting this once I get the Zoom recording back. Thank you for attending. Thank y'all. I really appreciate it. Have a great night. Go to bed. Make sure you get a good night's sleep. So important. My mom always tells me to get a good night's sleep. Thank y'all. I really appreciate it. Happy to help. Good luck. I hope y'all do great. See you tomorrow. Yes, I'm gonna get ready for bed and then I'll upload it real quick. Yep. Happy to help. Good luck.